Hi everyone, welcome to the stream. Today I will, well, today there will be a sort of C++ course stream session, and as usual, I'm streaming on three different services. What people call, how many people are there? 17 viewers. That's nice. Thank you for watching. Hi, SRG underscore T. So basically, if you haven't voted on the today's poll, please do, which is there's a question on your experience level with classes, because it's much more easy to explain classes if you have already used them, and if you don't know what are classes, it would be a bit difficult. And I'm not sure if it would be easy for me to explain what are classes to a complete beginners. I don't quite remember what it's like to not understand what are classes. So yeah, please vote on that, and I will explain shortly. And there is actually another poll. Another poll is this. I posted a link during my past stream, which is basically is a question about should I make slides? Do you think that I should make slides? And so it's kind of like 50-50 right now. So, but please vote. And if you feel like I should prepare slides, I will do. But for today, I decided to not prepare slides because I had only like 1 hour to do so, and I figured I would just start with demos. And the split is like 50-50, and now it's like the majority feels that I should do just demos. Yeah. Okay. Slides don't have to be overly long and overly complicated. I could just explain some sort of summary during the first 15 minutes. I don't know. Just let me know how you feel in this poll and in chat. Yeah, demos are in a way a bit more simpler for me to do because well, I don't have to prepare slides. Yeah. Okay. So okay, the majority knows about classes, and yeah. Okay, let me open chat here. Okay, basically ask me questions about classes as I explain them. And basically to some people who don't know what are classes, classes is a sort of so object and class. So okay, let me explain. Classes is a way to create your own type, and let me show you something like that. The most one of the ways, like people who really love object-oriented programming feel that objects should correspond to real-world objects. So, for example, if you are doing some sort of, I don't know, so like there are always these synthetic examples like car, engine, and like there is class car that has sort of like field engine, and well, so basically people who are really like object-oriented programming feel like objects should always correspond to like real world objects. So if you have like in a real world you have chair and you are making some program that involves chairs, you should well have a class chair. I'm oversimplifying a bit, but not a lot. Not, but it's essentially true. Um, in my opinion, in the real world, it's not that easy, and like the best way to figure out how to split your program into classes and what classes should be there is to try to think about your program and figure out what how should you group things together. So sometimes you have it's fairly easy. So you may have class user, and this class user have fields or attributes depending on the language. Um, yeah, and yeah, engine should be private. Yeah, I sort of should mention that. And there should be class public method start engine, And again, like for some reason, all books I read about object-oriented programming use these synthetic examples. Um, so yeah, so in my opinion, it's the best way to look at classes. Yeah, I'm going to explain this very soon. Just as we finish a couple more sentences. So basically, in my opinion, the best way to look at classes is a way to group things together, and just try to group things. Just try to group things together in a logical fashion. So, for example, sometimes it's really easy. So if you are doing some sort of if you are, for example, doing circles, you may end up having class circle, which will have several fields like obviously its center, like x coordinate, y coordinate, and z coordinate. Oh, sorry, no z coordinate, just vectors. So okay, let me show you. So I will probably show how I approach this program after these small, somewhat artificial demonstrations. Yeah, because we have this Tetris game that I'm building on Steam, and you will see how I use classes in the real world. Because during the previous stream, I developed something that looks a bit like Tetris, but not quite. So basically, it's unfinished Tetris. It's unfinished, and it needs some refactoring, and so I will show you. Yeah, some demos. Okay, looks like people feel a lot more. People feel like there should be just demos, at least most people. So yeah, let me check this. So let's go. Basically, here is how you define a class here, and I assume that most people know about classes. So just actually let me do some sort of hello world first. Really quick. It's actually clan++. For some reason, G++ in OS X is just the same thing as clan++. Don't ask me why though. There are different headers. Okay, let's go. Here's actually that does it work? Yes. Okay, let's define a class. And sometimes, so basically, a class is a way to define a new type. So let's say we want to have a class point, and classes can have fields, and they also can have they're in C++. So I should have checked the terminology. So the sort of official terminology is data member, which is that's just like fields, data fields. Actually, let me check it. Yeah, okay, it's member function, data members. Although I will call them methods and fields. So here's how we group values in C++. And let's say it's a point. Let's actually make it double because double makes more sense. So here's how we define a class that has two values. And C++ classes can have constructors, and constructors is a special type, is a special function that returns no value, and it basically constructs a class. It may do some complex things in it, but it also may do some really simple things. And basically, let's define a constructor that initializes our class just using two different numbers. Let's make them let's make these fields uppercase. The name of them of the fields uppercase. Double Y. And damn it, the more I think about C++ classes, the more I lose the idea of how to explain that. But basically, okay, let's talk about that. Let me explain that. And so constructors are special functions that take care about constructing a class. Sometimes it's necessary to allocate memory. Sometimes it's necessary to open a file. And you can do all sorts of complex things in them, and they are executed when you create a class, when you instantiate a class, which means that not when you create a class, when you instantiate a class, or which means when you create an object of this class. So for example, here let me add some debug information. Let's call it, and I think that actually I don't remember. Do Java has constructors? I think it does. Yeah, I'm pretty sure it does. In Python, a constructor is like in C++. So in Python we have init method, and it's a pretty similar thing. Doesn't it just make data members valid? Like if you had a linked list, it would set head to null. Okay. I will explain this shortly. This is actually a very interesting thing. Okay, let's define. Basically, yeah, let's define something. Called constructor using parameters. And let's just add parameter x, parameter y, and let's add the handle, which is a new line. And of course, let's do this. Okay. Let's create a point. So here's how we can create an instance of a class, and we have a class here. Oops, let's say it's 42.0 and I don't know 17.5. And here we have point, and then we can access members or fields using dot syntax. So it's just p.x and p.y. Okay. So here's what happens. As you can see, the constructor is called here. So in between these two lines, the special constructor, the special function is called this one. Okay. The question is here: what happens? Does it just make data members valid? That's a good question, because what happens if we define no constructors? No constructor. What would happen? Will it compile, or maybe it won't compile? Let's just comment it out. Let's see what happens. And as you can guess, it compiles. And it just says 0, 0, which is actually an interesting thing. Basically, the thing is that there are several different. So basically, there is. So let's say you don't define a constructor like we did. What happens? It turns out that the compiler generates certain constructors for you. the first constructor is called the default constructor. The default constructor is this. No, not that. Here's how it looks like, and there is like basically it's auto-generated. So auto-generated stuff here. Well, that's one way to look at it. And again, if you don't define this, a compiler is going to automatically generate one for you. So what happens in this things? What happens there? Basically, I should have checked that, but first, if I should have checked the correct terminology, but as you know that you might know that there are certain containers, and containers are just like classes, but they already come with the standard library. So, for example, what about list type? There is a list type in C++, or it's template, but we can define a list here. So, for example, a list of integers. Will it be initialized? Will it be in some sort of proper state, right? Will it be in some sort of correct state? And it turns out that it will be in a correct state because the compiler is going to call this constructor for you automatically. You don't have to call it. And in the same way, we had here a class. Classes in C++ are so much different than in Python. That's true. I mean, there are a lot of. I wouldn't say that there are different in a logical sense, but there are lots of technical details that make them fairly different. I just wanted to make sure that you have basic understanding of what class is and why do we need them. Okay, so what happens if we have this constructor that we wrote? What the hell? Why wasn't it able to compile? Oh, okay, makes sense. Okay, but if we define a constructor, the default constructor, which takes no arguments, will not be generated. That's how C++ works. So we can't generate just point.p. We have to call this constructor, or well, we don't call it explicitly, but we have to use it. Okay, and it works. And will this list be in a correct state? And yes, it turns out that it will be in a correct state. And basically, this is because if you don't call constructor explicitly, a compiler is going to call one for you, the default constructor. And the default constructor is the constructor that takes no arguments. And because it takes no arguments, compiler knows how to call it. Well, just provide no arguments and it will work. So, for example, here, let's actually don't use a list. Let's use a vector because, well, I don't remember how to use list. I need to check that, and well, using list is very rare. I don't actually remember if I ever used a list in production, but vectors are used all the time, and vectors are great. So let's have a vector here. Let me show you that I'm not lying to you, and it's actually initialized, and it's going to be an empty vector. right? What the hell? Oh, it's p size, and we need to call this. We need to use dot syntax to call. And again, you can see that the size here is 0. I don't think the default constructors do anything. They can do a lot of stuff. I can show you how to use the default constructor here. You can define your own default constructor. Default constructor is a constructor that takes no arguments, and you can define your own default constructor so it takes so it does something interesting. I'm going to show you this real quick. Actually, one thing I don't remember is what happens if you don't define a constructor and a compiler is going to generate. I mean, default constructor that is called if you don't include a constructor in the cloud. I don't think default constructors do anything. They definitely call the constructors of data members. So again, if you remove that, this vector is going to be properly initialized. So auto-generated constructor does call this. I mean, auto-generated the default constructor. And again, as you can see, vectors it works really nice. I guess so. One thing I don't remember is what happens to primitive types like double or int. Are they going to be initialized to 0? I don't think that, if I remember correctly, it is not guaranteed that they are going to be initialized to 0, but let me check it. Default constructor C++ primitive types. Again, yeah. I mean, the default constructor is called if you don't include, they won't be initialized by generate constructor. Okay, that's what I suspect. It's not the question I'm looking for. Implicitly defined by the compiler default constructor class that it does not initialize members of built-in types. Yes, that's true. So they won't be initialized by generated constructor, and it may seem weird because why if you define why if there is a data member of a class type of some sort of a class. So why does C++ initialize this and doesn't initialize this? In my opinion, it's kind of weird, but I think it stems from the fact that C++ has this philosophy, which means you don't pay for what you don't use. And since every okay, it's kind of advanced topic. So and since every C program, okay, that's how I'm going to phrase it. And since C++ is sort of backwards compatible with C, it means that C also has structures, and well, C++ structures and C++ classes are essentially the same thing. But C also had structures, and C++ added some, wanted to be backward compatible with C, and C structures aren't initialized by default. So that's why C++ structures and C++ classes aren't initialized by default. I mean, data members in them aren't initialized by default. Damn it. C++ is just so complicated because I mean, if I would design a language from scratch, I would make everything just initializable. I would initialize everything. Like I wouldn't make an exception for built-in types, right? Because it's kind of inconsistent. But you have to remember to initialize built-in types like doubles, integers, pointers. So yeah, C++ is kind of weird. I sometimes just kind of hate it. Sometimes I just hate to explain this because there are so many inconsistencies and it's kind of difficult to keep track of everything here. Anyway, this is something you have to remember. Just initialize the default. Just initialize the built-in types. Well, okay. I'm wondering if anyone bored by this. I hope that. Okay, some people are clearly bored, which sucks. Okay. Oh, so let's go. Okay, so but what happens if we want to initialize this vector with something? Another, like, actually we can initialize it. Well, you can write something like that. We can write something like that, which is also going to. Sometimes it's helpful to get junk value returned if you forget to assign value to variable, I guess. Yeah, but I don't know. Why don't return 0? Oh, okay, thanks. If you find this interesting, I will be happy to continue. But kind of feel that it's just C++ is just sometimes so inconsistent. I mean, to begin with, just shouldn't make any sense. Like, why this isn't initialized and this is initialized. So another feature that is specific to constructors is initializers list. So it's called, another thing is called initializer list. Let me check if this is correct terminology. Maybe I'm wrong. No, not this. Wait a second. Maybe it's just list initialization. I just don't remember what's correct terminology in English. Because no, not this one. Maybe I'm confused. Wait a second. Oh, okay. Initializer list. Initializer list is used to initialize data members of class. List of members to be initialized with a constructor is comma separated. Okay. Yeah. So, okay, I'm not confusing anything, I'm right, but in C++ 11 there is another thing that's called initializer list. Yeah. So another thing that is somewhat related, but it has the same name. I don't know. Maybe it's called initialization list, actually. Okay. Because in Russian it's the same thing, but in English, okay, I will check the terminology next time. This initialization. No, that's not that, not this thing. Or maybe member initializer list. Okay, not to be confused with std initializer list. Okay. So I'm correct. I wasn't confusing, but now I'm just wondering why they have two different things under essentially the same name. So that's what I'm going to talk about. And here's what you can do. Sometimes it's necessary to. So basically, the thing is, this code is going to be executed only after the object is constructed. So in this, in this code. So this code is going to be executed only after, well, not only after an object is constructed, but only after. So it's not constructed until the constructor is reached its end. Basically, it's going to be executed only after the default constructors are called, and so everything that should be initialized is initialized, and you can make further adjustments. I hope that makes sense. If it doesn't, let me know. And there is sometimes you need to call constructors explicitly. So, for example, you want to initialize vector, right? Outside of the program, outside of a constructor, you can init const member by init list. Oh, that's true, or that's actually a good example. A const member is a great example. Okay, so another example is when you want to call a constructor explicitly, or for example, you don't have a constructor, a default constructor. So sometimes objects don't have a default constructor. I'm wondering if there is. Actually, I think there is an example, but with const body hands. You mean okay? I think that you can, if you have const int x like for 42. Alright, let's call it full. I don't think that you can initialize it here, although maybe I'm wrong. Yeah, read-only variable is not assignable. Here you can see that it's not assignable, and yeah, it's a great example of split initial list. So sometimes you have to initialize use initialized lists, like when you have consts. Sometimes things have to be initialized this way. For example, if I remember correctly, there is a class called fstream, which is for reading and writing from and to file, and I don't think that it has. I don't think that it has a default constructor, although maybe it does. Oh, okay, it does have a default constructor. Okay, I guess it makes sense. I'm not sure if there is a good example in a standard library, but sometimes you don't have a sometimes you have to call a constructor explicitly. Okay, let me show you this on a vector. So let's say I want to create a vector of 10 elements and initialize them with fives. So normally we would do outside of the constructor, we would simply do this. Vector int 5, and let's initialize them. Okay, 10 elements, and all of them are fives. So 10 fives. And we do this. Let's give it a name. Right? So that's what we do when we want to have a vector of 10 elements. Every of them is 5. So if you want to do the same thing in a constructor, you need to use initialize list, and that's how we use. We add a column here, and then we basically write a list of these things that looks a lot like this, but not quite. So a list of 10 fives is going to look like that. And let me show you that I didn't cheat, and it's indeed a list of 10 fives. Let's actually output a fifth element. Seriously, I hope that makes sense. I just feel that C++ is just so unnecessarily complicated for a beginner. Do you think the vector is automatically initialized because of associated methods? Well, vector is automatically initialized because it has a default constructor, and it makes sense to initial. I mean, it makes sense to add a default. Like it makes sense to add a default constructor to a vector, right? Let's just. It's very natural for it to be automatically initialized to be of size 0, right? So I think it's really great. I mean, nearly everything in C++, I mean, like I mean, again, I should have checked a correct terminology. I know that it's correct to say that every class has a constructor, but does integer have a constructor? Like, for example, does this thing have a constructor? I'm not sure. C++ built in types constructor. Like, is it correct to say that they have default constructors? So non-class types, including fundamental types, array types, reference types, pointer types, and num types do not have constructors. Okay, so at least I was right to be careful about not saying that. Can't understand what vec5 does. p.vec5 just returns fifth element of a vector. So it's like 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and there are like there are like 10 fives, and it just returns fifth 5. Well, I hope that makes sense. You can also return 9, 5, and it will be again a 5. We can also modify things using this syntax. So you can write pvec 0 and write the 1. And the first element is going to be changed. Well, not first, but the 0th element is going to be changed to 1. Oh. So, okay, so what about constructors? So, in C++, classes have constructors, and like every class have a constructor. You can't instantiate a class. You can create an object of a class that has no constructors. Although, well, this is not entirely true because there is inheritance. But let me, although, okay, it's an interesting thing. Okay, yeah, I'm right. Vector 10.5 creates a list of 10 ins. Yes, exactly. The first argument is just size, and the second argument is default value. So it's a list of 10 integers with value 5. So in C++, everything has, not everything, okay, every class has a constructor, and some of these constructors are automatically generated, and many of these classes have also default constructors. And they have default constructors because it's super convenient. It's super convenient to have a vector to be initialized with some sort of default state, right? It just makes sense for it to be initialized with an empty vector. It's not always true. For some of the classes, it may not make sense to have a default state. Actually, what would be a good example? Let me think of one. I don't know. Nothing comes to my mind, but just sometimes it just doesn't make sense to have a default state. So sometimes you want to require, um, sometimes you don't want to have a default constructor, but oftentimes you need one because it's super convenient. And after that, you can safely call any associated method like pushback and etc. Okay, so what now? Another thing another special function is called distractor. And to define a distractor, you define this. And here you can do certain stuff. Again, by default, C++ is going to take care of many things. So we don't really have to call a distractor of vector. And vector has a distractor. And so it's going to be automatically, like every distractor is going to be automatically called here. But sometimes you need to do other stuff here. Like release memory or close a file that you opened before. And maybe just, I don't know if it makes sense to you to have a distractor. If you have some, so if you know about programming quite a bit, or you have a lot of experience using other languages, you should probably look into idiom called RAII, which means resource acquisition is initialization. But if you don't have much experience, don't bother. So destructor. And again, the thing about all these special functions is that they are going to be called in certain points. So, for example, when distractor of a point class, well, for some reason it has now a vector inside it, but okay, I should have prepared a bit better demo. So again, everything that has a constructor has a distractor. And the good thing about distractor that it's going to be called at certain points. For example, when this distractor is called a distractor of a class point, the distractor of class vector is also going to be called, which is really amazing. It's like super great. Like C++ takes care of many things, but like I mentioned, sometimes you have to close files, release memory, and so on. Basically, release some sort of resource. And if you don't define a destructor, C++ compiler is going to generate. Oh, yeah. Why there is no? Okay, I forgot to write it. Yes, thanks for pointing this out. I should have wrote this. Yeah. Basically, it's going to be initialize x and y this way. So you can initialize x and y this way, and and you should and this way of initialization is the preferred way. So you should probably initialize your data members using this. These lists of initializations and not just write an x equals x here, y equals y here. This is less preferred. So stick to using lists of initializations. Yeah, by the way, you are not backtracking me. I'm happy to receive questions and thank you for the catch. So what now? Again, another thing when destructor is called is at the end of the block. So at the end of the code block, which is designated by curly braces, all objects that were created inside this block are going to be destroyed by calling destructor, and the compiler does this automatically, which is really amazing if you think about it. I mean, it's really amazing compared to C. For example, in Java or C# or Python, there is a thing called garbage collection, which even more high-level stuff. Again, in a way, C++ is kind of low-level language. It gives programmer a lot of control over how the program is going to be executed. And compared to C, there is very little overhead. I mean, if you want to write your program with no overhead, you can do that. And if you want to use some cool features, or if you don't want to bother with performance, can you show an example of struct execution? Like that. Like this destructor is just calls. So here we have class point, right? We created it here, and at the end of the main function, this destructor is going to be called, and here's the output. Again, this is very simple example, and it's again a bit artificial, and it's very likely that when I start writing code today, we will not use any destructors. I mean, we will use them, but they will be automatically generated by a compiler. Yeah, you're welcome. Again, I think that I've been talking for quite a long time, and okay, actually, I should have mentioned another. Since we are talking about constructors, I should mention another type of constructor. So there is copy constructor. And I should probably talk when C++ copies objects and when C++ doesn't copy objects. Yeah. Ooh. Again, like the course is going to be completely non-linear. So consider this version 1. Sorry, consider this version 0. Maybe somewhere else there is going to be a version 1 where I will talk in some sort of linear order, where everything makes sense to you. Okay. At least I feel like this is at least useful to some people. Again, copy constructor is defined like that, and again, by default, it is generated by a compiler. I'm not going to talk about copy constructor right now. I will probably talk a bit about them on Sunday. And copy constructors, you can guess, just copies an object. Sometimes it's really necessary. Well, oftentimes. So, okay, I will end talk. So now I'm going to end talking about this, and let me know if you have questions, because C++ is just fucking complicated. So, okay, now time for questions, and then I'm going to start writing code for Tetris, and I will start refactoring code using C++. Well, damn it. So I will start refactoring C++ code using classes. Oh, okay. So I just hope that it just makes sense. At least some of the stuff I talked about makes sense. Okay. Please let me know if you have questions. I will be happy to answer them. I should probably prepare more for these sessions. I just feel like to me everything feels like I already know that everything just so I understand everything, and everything seems so logical to me, either because I memorized it or because I used these features for years, and then I just start live streaming, and I just feel like, okay, I will do a couple more demos. Like, I will do a couple demos, and I will talk about I already know, but when I start talking, I just feel like C++ has so many complications, sometimes there are just certain inconsistencies, inconsistencies, and sometimes it's just very unfriendly to beginner. So yeah, which maybe I should start preparing more. Okay, let me know if you have questions because I will be really happy to answer them. And maybe you have some unrelated questions. I mean, unrelated to classes. Maybe you are learning about templates, or maybe you're learning about how C++ does input and output. So please let me know. I will be happy to answer them. And yeah, let's start. And after that, let's start coding. Kind of feel like the amazing thing about live streams is that you can ask me questions in real time. So please do it. Okay, so I will go away from keyboard. Do you have your TEDx code on GitHub? Yes, I do. Okay, I will go away from keyboard for a couple minutes. So if you have questions, let me know, and yeah, I will answer them, or I will reach after I will return. Hi, I'm back. So now there are some questions about things. Yeah, you started telling the previous session, right? Yeah, I did start Tetris during the previous session. Although I did some sort of small demo using SFML library 2 episodes ago. So yeah, but the majority of things were done during the previous session. Yeah, so that's true. Um, so yeah, okay, see you again. If you're not here, the students are just explicitly deleting heap objects, not necessarily. Basically, the structures are necessary for everything. And for example, this object, here's the small artificial program, well, synthetic program that I wrote. Here's a vector, right? And it's just constructed, but it's not allocated on stack, or it's not allocated on heap. It is allocated on stack. And anyway, it still needs destructor. Although it's not entirely true to say that the actor is allocated on um, on stack. I mean, here's how it looks. What it looks like. And this is fairly. Maybe it's a somewhat advanced topic. So don't worry if you can't understand that. I will probably explain about heaps and stacks and whatnot somewhere later. But to people who already know what stack and heap is, here's some sort of how things look like. Basically, a vector is this. It's a pointer, and it's a size. There are probably other things, but there are probably other members that a vector contains, but these two are most important. And basically, the vector itself, which means like a pointer and its size, are allocated on stack, which is why I said that this vector is allocated on stack. But it also has a pointer that points to a memory, and this memory is allocated on heap. Well, so yeah, so that's how it looks like. But destructors are called for like any object. When any object is, well, I mean, destructor. I mean, what I'm trying to say is that destructors are not for explicitly deleting heap objects. Sometimes sometimes you need to call destructors explicitly, and sometimes you need to call delete function that deletes stuff that is allocated on heap, and it calls a destructor. But for things that are allocated on heap on stack, destructors are going to be called automatically, and there are still destructors, so they are not just for things that are allocated on heap. So I hope that makes sense. And now I'm going to refactor Tetris. Well, Tetris. Here's what it looks like. Oh, and well, it now comes to the fun part for me, because the previous hour was like not easy for me, because like I mentioned, it seems so logical and easy and obvious until you start explaining it. C++ is just very interesting, very complicated language. Okay, let me show you something, which is the current state of the Tetris. And to people who are interested in the current code, it is available on GitHub, and it's somewhat it's not pretty. So we are going to refactor it today. Ooh, okay, let's write some code. Let's compile it and oh damn it. FML graphics, minus FML something some FML what system FML window. Um, yeah, you are probably right. Let's test it. Okay, it compiled just fine. Okay, so what it looks like? It's not Tetris yet. It looks somewhat like Tetris, but it's unfinished Tetris. So there is a figure that I'm able to move using arrows. There is some sort of a thing that looks like a field. Again, not quite, but it looks somewhat similar to field. Oh, what's next? And the current code isn't pretty, and you need to refactor it. I deliberately avoided using classes because I hoped that I will be able to explain them well, and at least I hope that I helped someone to improve their understanding of C++. Alright, enough playing. Let me show the code. So here's the code. And yeah, it's kind of ugly. Alright, so there's certain things that... Oh, and I didn't explain how to use functions. I completely forgot about other functions. But okay, I will going to show you how to use them. So classes. Basically, right now we have a vector. Here's our global state, and let's create a class called GameState. It's going to hold the state of the game. And I forgot to explain public. Oh damn it! Even constructors are there are so many details about constructors. So it's just so not easy to explain them in a short amount of time. Okay, so basically there are public members that are accessible outside of a class, and there are private members that are accessible only to within the class itself, and there are also protected members, which I'm not going to talk much about, but they're accessible within class hierarchy itself. And here's what I mean. Let me show you. Okay, so let's refactor it. First of all, let's have a field. All right. So let's make it private because it doesn't make sense to make it available outside of this class. So it won't be accessed, at least for now. Maybe later we will decide that it's necessary, but now not. And okay, by default field is 20 by 10, right? 20 by 10 squares. So let's create a constructor that will initialize this. So it takes field and it calls its constructor, and well, and then nothing. Okay, so it works. Although there is now a lot of errors called use of an undeclared identifier field. This is because it's no longer available here, right? Now it's only like that. So let's also take these things And let's refactor step by step, and let's just put them here too. There is now a figure that needs to be initialized as well. So let's put it, and that figure is well, the thing that moves here, right? So the field is everything that's drawn here, and the figure just moves around. And yeah, and there is square at the top left corner. It's just an artifact. Ignore it for now. So okay, let's initialize it again. So so it's 4x4 thing, and again, not everything works perfectly. We can't rotate it yet, but let's work step by step because that's first how I work, and second is how I think it's much better to work. It's much better to just work step by step. This initialization code looks kind of ugly, but we are going to refactor it later. For now, let's just put it into a constructor where it probably belongs, right? So let's initialize it again. Let's try to do ugly, handle it in a better way. Okay, what about this? What can we initialize it here? And not unless we are using C++ 11, and we are not using C++ 11 yet. So just let's initialize it here. So again, this stuff is called list of initializations, or maybe initialization list. I don't remember the proper terminology in English. And the whole thing is called a constructor, right? And since it has no arguments whatsoever, it's called a default constructor, or sometimes no arguments constructor. And again, we explicitly declare it, and that means that compiler is not going to generate some code for this default constructor, and well, it's going to use our code. And as you can see, both of these vectors are initialized here, and we explicitly call non-default constructors. If we remove these two lines, right, both of these vectors are going to be initialized with just empty vectors. That's not what we want, and that's why we initialize them with zeros. And they're just matrices that we initialize with zeros. Matrices of this different size. What's next? Now we have draw matrix thing. Honestly, I don't know if we should put this draw matrix in this class, because maybe it would be better to separate state from its how it looks like. So state from GUI, state from interface, maybe it should be separated. I don't know. I don't know yet. So, but for now, why not just we put it here? Like I mentioned, I mentioned this before, and like in every object-oriented book, it always seems like splitting stuff into objects is just like easy. Just look at your problem, look at the real world objects, and just try to create corresponding classes. Maybe I read not the best books, but that's how it looked to me. And basically now I tend to look at classes not as some sort of real world object, but just as a way of logically group things together. I also don't like over-engineered solutions, and yeah. So here's that. Although you have some ideas of how to draw things. So, for example, let's say so why having so if you're wondering why having geomatrix function may be a bad idea here, it's because, for example, we want to code a board for Tetris, right? And board doesn't draw anything, and so it just manipulates state. And for example, it can send things over network connection, and so we would need another function that takes borrowed state and sends everything to over a network connection. So there are different. So my point here is that there are different ways of organizing your code. It really depends on what you are building and what you are trying to achieve. And generally, I think you should avoid over-engineering solutions. So for now, we are leaving geomatrix here. Right. So leaving here. Okay, so it sets here. It's a function, and so yeah, nice function. And actually, since it's not quite just game state, let's call it a game, because it represents not only. Maybe game is a bad name. I don't know. Let's call it a game. It's certainly better than just calling it game state. So it kind of handles two things. First, it handles first it stores state inside it, like fields and positions of a current figure. And the second thing that it does, it can draw the state. So it makes more sense to call it game rather than game state. Okay, what we have right now, what we have here. Okay, we have ways to. So okay, we have geomatrix. Let's move geomatrix into some sort of a method. Let's just call it draw. Again. And by the way, for people who know Python, in Python you have to specify Python that would look like this, right? It would look like def draw self. In C++, you don't have to specify self manually. It is available to you implicitly, but it's called not self. It's called this. So in Python you have self, and C++ you have this. What was it doing? Okay, let's name it to draw matrix starting with capital D. Let's call it here. Okay, we have a bunch of stuff here, and there is a user of undeclared identifier window. Let's pass window here. And okay, there are four more errors. So here's the difference between private and public. So we have, let's instantiate a game here. And instantiating game, I mean let's create a game. So we're creating a class game here, and so we have an instance of it. We have a game object here, and we can use it. We could write that, but right, we can write it. But what does it say? It says it's private member of game. So it means that it's accessible only within the game class. So what's the difference between private and public? If you declare these two things public, then you can modify them outside of this class. Alright, so there are now no compile errors. So let's try compiling it and see if it works. Oh, and it didn't. Why? This is probably because we have this method, but we don't call it. So let's call it game draw, right? Too few arguments. Oh, we need to provide a window. So this method draws on window, and we are going to see essentially the same thing now with classes. The code looks a bit better because now we can do really nice stuff. So, for example, I just think that it would be better to not modify these variables from here. It would be better to define a new function, basically, or four different functions. So let's make them private, and let's define a few functions. The first function is going to be called move right. The second one is going to be called move left. Let's since we are already trying to implement Tetris, we can't move figures up and down, right? So I can do it now, but it's just not what it should look like, right? It's not some sort of weird game. It's just a Tetris. So let's define two functions: move up, move right, move left. But let's not define move right and move. Damn it! Let's not define move up and move down, even though we can move the current figure up and down. So and here we don't have to specify an instance. It's available automatically. So this code is going to modify these two variables. As a private member of game. So what doesn't? Oh yeah. Let's remove here. Let's remove these two things here. Although, like some Tetris is allowed to to move down, and you know what? Maybe we should allow this too. So let's actually define move down. I think defining move down would make sense. Void move down. So again, remove it here. By the way, if you have any questions, just don't hesitate to ask me. Don't be shy. I love answering questions. Okay, maybe you can see this, but I can't move the figure, and this is because I didn't call it here. So let's call move left here, right? So we tell game instance to move left. Actually, moving left is a kind of bad name because it sort of it kind of reads like we are moving the whole game left. So let's rename it to move figure left, move figure right, and move figure down. I think it would be a better name. Move figure down. Do we have these methods implemented? Yes. Okay, let's compile this. Okay, now I can move it up and down, left and right. Although you probably can see it, but this should be a decrement and this should be an increment. So, okay. Can't really move it up now. Can move it left and right, and well, there is no boundaries check. Now we had some sort of constants here, somewhere here. For example, square size, outline thickness, matrix position X, matrix position Y. Actually, we are going to leave it right here. Other questions? No. Okay, that's fine, isn't it? Okay. But we need size. Oh no, wait a second. We don't have size. So you know what? Let's have let's define. Yeah, let's define size here. Like let's call it width, and let's call it height. Field width, field height. There are different ways of defining constants in C++. Let's just use this one. And let's move this up. And let's define this. Field width should be 20. Field height should be 7. This should be 10. This should be 20. Oh, it's horizontal now. What the hell? Probably because we should use height here and width here. Okay. Okay, works now. Now let's get rid of certain artifacts. Like let's get rid of square. How would it be? How to factor this? We have here is a bunch of stuff. So some of them is really specific to drawing a border. Okay, let's have a class. First is going to be called draw field and function, and let's remove this part from here. Let's call another function called draw matrix. Although maybe we should have an entire new class for how do you take your tea? Lemon, milk, sugar. It's just a plain black tea. No lemon, no milk, no sugar. Although, wait a second, this is a tea with some sort of aromatizer added. I think it has lemon, just not actual fruit. I don't know, do people outside Russia drink tea with milk? I heard it's like a Russian thing. What does savage mean? Let me check it. Okay, in Poland too. Okay, yeah. In other countries, do people do? Yeah, I know. Because okay, yes, this is because you live in Russia, and it makes sense to me. In Russia, people do drink tea with milk. I personally don't like this, but that's just my personal preference. So let's have a class draw matrix. It's going to take render window. And now I feel like maybe we should have Russian tea glass. Oh, I only saw these glasses on trains. I never saw anyone using such glass in their own home. So such glasses are used in trains, but I don't know. No, I disagree. I like my tea without any additions, except occasional aromatizers. But most of the time, yeah, I actually like my favorite sort of tea. My favorite kind of tea is Earl Grey. I think it has some what's that? Some that bergamot, and it's in English. In English, it's bergamot too. Bergamot. My cup is from Russia, but it's never. But it doesn't look like on that picture. It doesn't look like anything like that. It looks like just, I guess, a normal cup. You see it? Yeah. Um, so, okay. How many people are still there? 14 viewers. Okay, so at least the quoting part is fun. Or maybe 7 people. Tea with milk is common. I do it. Green tea, nah. Yeah, I don't think that people here drink. I think that people here don't drink green tea with milk. I never heard about this, but drinking black tea with milk is very common. Oh, thank you for subscribing, by the way. I don't know. I actually many people like drinking tea with sugar. Many people like drinking tea with milk. Yeah, sometimes people drink tea with honey. Alright, let's add a matrix here. And we should probably do it at there. Talking about tea, do you recommend any I like Earl Grey, but I'm no expert in teas. So my favorite one is Earl Grey. I forgot the brand. I never remember the brand. Is it? I never remember. It's just that yellow pack of Earl Grey. I just go there. I just go to a shop, to a grocery store, and I just buy this yellow pack of Earl Grey. I forgot the name of the brand. No, not this one. It's red and it's really cheap. I don't like it. At least for me, it's not the way to. Not Lipton. Sometimes I buy Lipton, but Lipton I don't like Lipton too. I buy Lipton when there is no when there is no when there is when damn it, grammar is so hard sometimes. So I don't. So I buy Lipton only when there is no tea of my favorite brand. I'm pretty sure it's like an actual dust. The, maybe I buy Twinings. Actually, let me check it. It's just maybe it's Twinings. Yeah, I buy Twinings. That's what I like. Yeah, this yellow pack. Maybe it's a bad tea, but it's the. I mean, it's the best tea I tried in Russia. Maybe there are better teas, and I actually tasted some expensive teas that's available here. Because, well, why not? And to me, it feels nice. It has a good ratio of price to quality. So it's not a cheap tea, but it's not too expensive. Okay, I have another brand. Well, not a brand, but a kind of tea that I like called Puer, and it's really great. And okay, spelled sometimes it's spelled differently. It's really stimulating. Very nice tea. Uh, it's I don't think it's a black tea. It's kind of a weird fermented tea, and it's really great. I don't drink it at home, but whenever I go to a restaurant and there is a pu'er tea, I always order this stuff. This stuff is great. Really energizing. Um, yeah, okay, that's really cool. So you are Ukrainian living in Spain. You should try it. It's great too. It's if you buy it, it can be somewhat expensive, but I think it's worth it. Although I rarely drink it at home. Like I don't think I haven't drink it in like 2 or 3 years at home. Yeah, especially it's 12 years old. Oh yeah, let me check it. I'm not sure if this brand is available in Russia. Lions tea. Oh, I don't think I saw this one. Maybe Barbaris. So maybe no, I don't think. I think I never saw this one too. Um, Maybe let's type by. Doesn't look like there is it is available in Russia. Um, I don't know. If you don't get it, then don't drink it. It's just a very energizing tea with interesting taste to me. So it's not really that special, but it's more energizing that's normal tea. I think it's very low in caffeine, but it's still pretty energizing, and it's a very interesting feeling. Um, yeah, and I like its taste. Well, maybe I don't know. Maybe it affects some people in a different way, differently. Oh, so when there is no alternative. Yeah. By the way, yeah. So I don't really, I don't. So I probably can't really recommend the tea, but like I mentioned, I drink Twinings, and occasionally I drink pu'er, but but only when I go to a restaurant. Yeah. So um, topic discussion seems to be really popular. A few days ago, we had a really nice stream. I was going to start a project in Python, but the stream got completely sidetracked, and we ended up chatting about a lot of different stuff from like programming, politics, Putin, Crimea, um, culture, different interesting links, illusions. So it was pretty nice. I think you were there. I think Mike was there. So okay, let's create a geomatrix theme. Um, I d- Actually I don't like what. So I'm not a fan of Java and I don't like coffee. So I don't think there will be an episode on Java and coffee. Java minus minus, yeah. Okay. Okay, I'm going to use a enum here. So another way of defining constants is using enums, and that's what I do the most of the time. So people often define anonymous enums, and they have a number there. Let's actually create one enum for everything. Okay, square size. Let's move it everything from here to draw matrix. Okay. Set X, offset Y. Okay, let's have these parameters for now. Again, I'm not sure. So the code is definitely getting better, but there is still room for improvement. Oops, matrix, draw field. Okay, draw field doesn't really require having a parameter here, so let's just pass field here to draw matrix class. So let's pass window field. That's an interesting observation. Let's pass offset. Actually, we don't need to have offset here. I think we don't need to. Yes. Let's not pass offset here. So we just have a draw field function that draws field. And let's use a field here instead of a matrix. But there is something like matrix width. Yeah, okay, let's use field name field here. And we need position X. Oh, phew. Okay. Let's have field position X here. Field. Actually, let's make them constants. And yeah, let's use it here. Matrix. Okay. Matrix position X, and it's called now it's called field position X. Matrix position Y, it's called field position Y. Square set color. What's color? Okay, color. Okay, let's just copy that. For now, because later we are going to bundle color with the figure itself in a single class, so there won't be just std vector of std vectors of integers. That won't, and we will have. So okay, let me explain it more clear. So there won't be this. This is going to be not just a vector of vectors of integers. It's going to be a separate class of which will have some interesting functions like ability to rotate and so on. But and that's why I'm copying just this color definition here. Let's actually change it to something like something more interesting. Maybe to something like that. I don't know. Although, wait a second, we don't have draw field. Color isn't used there. So, okay, we just need to set it here. Okay, let's leave it like that. Field position Y. Matrix height is not declared. Okay, let's have matrix height, matrix width here. Again, this kind of looks like copy and paste, and we should get rid of that. But again, let's do it later. Let's just refactor step by step. Nothing happened. What the hell? Oh, there was some sort of thing. Okay, let's see. Draw matrix. We're going to call draw field. Suggest me a good film, guys. In what genre? One of the last film that I watched was Predestination. It's a really cool film. I'm not going to talk about the film, but it's better. It's a sci-fi film about I will try not to spoil that. Oh, okay. So we have draw field here. Oh, it's a window. I love films like Interstellar about black holes and cosmos. Well, you may like Predestination. It's a sci-fi movie. It's not about space, but it's about other interesting physical concepts. I will try to avoid spoiling this. So I want to talk about. Is it about time? Yes, it's about time traveling, and it's actually based on I think Robert Heinlein story called All You Zombies. All You Zombies. So it's, Predestination is based on All You Zombies by Heinlein, I think. All You Zombies. Yeah, it's by Robert Heinlein. I hope I spelled his name correctly. And if you don't want to watch it, you can read this story. It's pretty short and it's a fun story to read. But if you want to watch the movie, don't read this story because the movie is heavily based on this story. It's like 2/3 of the plot is this story. So it is fun to watch it after reading the story, but if you didn't read it, you should probably watch it without reading it. Unfortunately, I already read it before I watched Predestination. So and that's how I found this movie. So actually, it wasn't me who found this movie, but it was my girlfriend, and so she somehow found this movie, but she found it only after I recommended this story to her. So we watched it after reading the story. which was fun, but I think that you shouldn't. You should avoid reading it until you watch the movie. Okay, so I feel like I'm using too many words. Oh, Geomatrix isn't working. I think it stopped working after the refactoring, which happens all the time. Oh, wait a second. Geomatrix figure, right? It should be big. No, wait a second. No, I'm incorrect. It should be window. Geomatrix takes a vectors. So it stopped working. Why? I have no idea. Is the okay? Yeah, I agree. Side checking is a lot of fun. 2 people are watching here. Wonder how many people are still there. 13 viewers. Okay, that's really nice. So what was I going to do? Oh, I was trying to debug this. So it stopped working. I don't know why. Oh, it is back. Okay, it is back, but why it wasn't drawn originally? Game draw calls this. Oh, I think I know this. Take lots of seconds. Oh no, maybe not. Let's see again. Oh, it is here. It's just the very end of it. Let's see at the PD. I don't know. Maybe it's okay. Maybe it is in a correct position. So 0, 0, I think should be the bottom of the field. So I think the figure is by default in the correct position. Let's put it at the. Yeah, kind of makes sense. Yeah, makes sense. So let's just update its y coordinate. Let's put it to 20. Okay, so here is it. So it kind of looks like Tetris. I think we should prevent this figure from moving outside of the borders. And to do this, we need to update move figure right, move figure left, and move figure down. So let's see. I think y is going to be at field 8. If figure x less than more than okay, if it's less than field width, then we are going to allow moving it to the right. Maybe -1. Yeah, probably -1. Okay, we need to -1 here, and we need again if it's more than 0 here, we will allow moving to the right. And if y more than 0, of course we need a more complex conditions, like checking for collisions. But for now, let's make sure that every basic stuff is work. Okay, doesn't work. Okay, and it works, but not entirely correctly, because every figure is 4x4 square matrix, and actually we need to make sure that there is no. So actually we need to have a fairly complicated logic. I don't know if you can see, but it can't move down, it can't move up, so it sort of works. I think that we are not going to update the code with the new logic, because I don't know how border checking is going to be implemented. I don't know how we are going to write collision check between a figure and a border. So I don't know. Let's leave it like that. It's not correct, but it's getting closer to it. So okay, it can move up. It can move. So it can't move up here. So yeah. Oh. Let's commit this. Again, let's push it. What now? So now I need to consider how it would be best to implement rotating, stuff like that. I know. Actually, I kind of need to think how to implement rotating. It's not super difficult, because we just need to create a class, and that has method rotate, and that cycles through the all possible rotations. But I'm actually I'm actually wondering how do Tetrises implement this, because it seems like you can't always rotate a figure, right? I think there are sometimes circumstances where you can't rotate a figure, so that's actually interesting. Now I'm actually starting to feel like maybe there is possible to implement the Tetris using not a grid, but like, right, so there is a grid and some squares are then sort of marked as occupied, but maybe there is a way to implement them as a unordered set of squares. This is kind of seems like a bad idea to me. I don't know if it makes sense, but imagine like a set of squares or a vector of squares, and yeah, it's probably a bad idea. So I kind of need to think about possible implementations. Generally, I think it shouldn't. It's not complicated. It's not difficult to implement it. It's just I'd like to do it in a concise fashion. So I'd like to write as little code as possible. So how long have I been streaming? I've been streaming for more than 2 hours. So I hope there are questions, because if there are no questions, I'm going to end the stream. Although, I don't know, maybe I shouldn't. How many viewers are there? 13 viewers. Okay, so if there are questions, so random questions, like just let me know. And I feel like I will end the stream after the questions, because I'm kind of tired, and I don't feel like there are much to do. The next thing that I'd like to implement would be figure rotating and like more advanced border collision checking, because right now we just limited the x and y coordinates of a figure, but it's not how it's supposed to work, right? Because this leads to look at it. Basically, look at how it doesn't work correctly. One way of doing border collision would be surround the field with fake squares, like I don't know, in the line editor. Okay, so to work for a company freelance. Right now, I'm working for on my own projects, like my own live streams and things like that. But before that, I worked in Yandex, which is a Russian search engine company. I worked there for 4 years, and I worked on a certain part of a web search engine. I can't go into much details because of non-disclosure agreements. So yeah, can't really talk about it. I mean, I can talk in general details. I use C++. I can talk, for example, on how Yandex uses C++. Have you ever made a Tetris similar? Yes, I did. I implemented Tetris in C++. It was done using Qt. And basically it worked like that. There was a grid, and there was, well, some basic, but I don't actually remember how the exact implementation details. It's just there are multiple ways of on how you can do border like collision checking, right? For example, let me show online editor, right? So the first thing is kind of obvious, right? You can write a special code for borders. So you make sure that no square within a figure is ever outside of a border, right? On the other hand, you can use a different approach. Here's how online painter. So I'm just thinking out loud because I think maybe people are interested in this. Sketch and Paint, let me show it. What the hell? I need something like GIMP or Jim. I don't know how to pronounce this. Timeline. Alright, let's enable Flash. Actually, no. Let's just some line. Oh, I hate Flash. Okay, let me show it here. Oh, okay, it's unfrozen. Let's just. I need something really simple. Maybe Sketchpad. Just a very simple application that I can show. Okay, this looks like good enough. So okay, imagine these are borders. This is a Tetris field, and I'm going to show you this using my math skills. So there are some figure like T, right? And well, there are no squares. Okay, it's not very convenient to show you. Anyway, actually, maybe I can pass the screenshot. So, okay, let me pass the screenshot there. Maybe it will be possible to. Doesn't work. Okay. Imagine that this is a square. I'm going to use another color. Okay. Imagine that red are squares and this yellow greenish color is imaginary borders. So basically you can as you can guess, there is going to be code that checks collision between squares, right? Because there can be squares here, square here, square here, square here, and it's not like obvious stuff. It can't move through squares, right? And there should be code that checks for this, right? So, but we also need to check to make sure that figure never moves outside of a field, like here, right? And we can check it in two ways. First is we can simply check that write a special code for handling for borders, or we can surround border, like make sure that field is surrounded by squares. So it looks like this. There are some fake invisible squares outside of a field that are not visible to a player, but are real for game. This way we can use square collision code to check for to make sure that figure never moves outside of the border, right? Because we can get it automatically or almost automatically. So which one is right? I don't know. It kind of depends. It depends. I feel like it may make logic a bit more complicated. So there is some trade-off. Or for example, so what another thing I was thinking about is how to implement moving down or rotating. So rotation is not always possible. Sometimes you can't rotate a figure. What is the advantage of using squares for borders? The advantage is there is no special code for handling so basically, okay, so first of all, you always have square collision code because you always need to make sure that figure can move down. Like right now we have it, we don't have it. So if this would be a real Tetris, the T piece wouldn't be able to move down, but it can now, right? if there is a square-square collision code, we can make sure that that this figure doesn't move outside of field just by surrounding field with squares, right? We don't need to write extra condition for borders. So for example, we don't need to write something like that. I'm going to open this. Will make difficult when destroying complete lines later. This may be true. So yeah, I guess you are right. So I feel like there is certain trade-offs, and this is probably not that great idea. Or for example, let's say we want to rotate a figure. We can't always rotate it, right? Should we rotate it? Check if we can rotate it, and if we can't rotate it, we roll back. Or should we kind of check before rotating and not do roll back? So if we code, so let me check it. Rotate it, right? So first way to do it, rotate, right? Rotate. If game is in an impossible state, then roll back. Or I feel like it's probably not a great idea too. Or check before rotating, right? Which one is better? It also comes down, basically, I'm not thinking this just out of blue. I'm thinking this because I'm thinking if we ever should copy our entire field. Because this could be implemented rather simply. If we decide that we are going to make checks by copying a field, making sure if it's in a valid state. Lots of checks can be implemented in this way. Can be implemented like this. Do a change. Check if a field in a valid state. And if it is, replace, or not a field, let's call it game state. And if it is, replace game state with a new state, right? And if it doesn't, do nothing. So basically, I'm thinking if we should use this. I feel like it may be super useful in certain cases. Like, for example, we can do, for example, how destroying completing lines would work if we use this design. It would work rather simply. We do this while basically new state, like updated state, doesn't equal to deleted, current state. Do this, move a line down and like updated. So sorry. I'll write it in like it's sort of pseudocode. And this like we do this. Updated current state. We replace current state with updated state. Then we do updated state equals to where we do move a line down, something like that. Again, a pseudocode. The actual code will be different. And yeah, so I'll like move a few lines down. Again, and this makes destroying completed lines really easy, because we just make one line down. We find like a first line that we can make down, and we move it down. We move a few lines down, and on the next iteration we make sure we check if this process converts, and if it converts, we like stop deleting lines and we start running game loop. We start and we resume running the game loop. On the other hand, there may be certain drawbacks to this approach. I don't know. Maybe this is a great approach, but maybe maybe there are certain drawbacks. I don't know. I feel like when I wrote my first Tetris, it wasn't written in this fashion, but now my intuition tells me that this approach may be better because it will result in a shorter code. I actually don't remember how I implemented deleting lines, but I definitely never copied the game state. And I feel like copying game state can be really amazing. I don't know. I need to think about it. It's not. Sometimes it's difficult to decide what should you do, and that's why most of the time I try to just write step by step. But sometimes you have to make crucial design decisions. Because I don't want to rewrite code. I'm pretty sure that there is always constant refactoring going on. You can never decide. You can never make sure you know everything in advance, and unless you have a lot of experience. So yeah, kind of tired. Yeah. Let me know if there are other questions. I just hope that these things make sense. I feel like maybe this loop, maybe this isn't really necessary. So, for example, a rotating can be implemented in the same way. So we copy game state, and if it's invalid, we kind of discard it, and yeah, we just carry on. And if it's valid, we just replace the current state with the updated state. I think that this approach has a good chance of making code shorter and simpler, but I'm not exactly sure. So yeah. What you gonna do on Sunday? I haven't decided yet. I think that I will probably talk about pointers versus references versus objects versus objects, and about object copying, passing by value / reference, something like that. I haven't decided yet. Do you think that I should prepare in advance? Because I feel like maybe the first hour was not that good. Maybe I should prepare in advance, do some sort of rehearsal. So yeah, David. Oof, how many people are still here? Okay, 11 viewers. Like I mentioned, I will end the stream unless there are more questions. I'm actually wondering. Oops. I'm actually wondering. Maybe. Yeah. Thanks. I did a live stream. I did a Python live stream before C++ live stream, and then I had to explain all these peculiarities of C++. And um, yeah, like I mentioned, it always seems so logical and obvious until you try to explain it, and that's where. Um, okay. Yeah, thank you very much for watching, by the way. Let me know if you have requests for specific C++ topics. I will be happy to do them. Like one time, Yumi, like it's one of the viewers, his nickname is Viewer. His nickname is Yumi. He requested to make a dynamic library, like a dynamically linked library. So I did I think, pretty cool live stream where I did some sort of compile time instantiation. It seems like every time I open YouTube, we are live. Yeah, I actually started live streaming every day. So I decided to stick to a schedule, and I live stream every day at 4 p.m. Python development. Okay, thank you very much. Thanks if you enjoyed. This is really great because I always worry that I think that there is definitely room for improvement. So if you have any ideas on how to improve this, let me know. If you have specific requests, specific questions, just let me know. I can do a session on whatever topic you want. But I worry that I'm kind of a noob teacher, so just like I mentioned, there is this weird effect that I realized exists. It always seems so logical until you explain it. Okay. Yeah, thank you very much. I really appreciate your support. Like I mentioned, I stream every day at 4 p.m. The C++ course schedule is. So wait a second. I don't stream every day, but my plan to stream every day until I implement this cool sort of cloud bash history application in Python. Then I will reflect on my experience and decide if I want to continue streaming daily. The C++ course schedule is Wednesdays, Fridays, and Sundays. And yeah, the next Sunday, like this Sunday, I'm probably going to talk about like references, pointers, objects, and copying, non-copying. Yeah, pass by pointers, pass by reference, pass by value. Oof. So yeah, it's 1 a.m. Wow, 14 viewers. Where did you guys come from? Like, if you have questions, let me know because I'm about to end the stream. Looks like there are 4 new viewers. So if you're here and you are watching this, let me know, say hi in chat and ask me some question. Otherwise, I will end the stream. Ooh. Yeah. I really enjoy streaming, but okay. And it's really great that you find this useful. Let me know if I should do more live streaming more live coding, or I should focus more on trying to explain C++ concepts. I know. maybe I should create a poll. Oh, so okay, pretty much everyone has some experience with classes. That's actually great. There are 2 new walls. Maybe more of the basic concept stuff, like what? If you make a specific request, I can do a Sunday session on it. Because I haven't decided what I'm going to do on Sunday, but if there are no requests, I will do this. So, yeah, tell me. Still 14 viewers, and you guys are lurkers. Okay, how are you going to cover raw pointers, smart pointers? I don't think I'm going to cover smart pointers. Smart pointers is an interesting concept. Smart pointers is amazing thing. I feel like I won't talk about them because before I explain everything about constructors, destructors, resource acquisition, and resource acquisition is initialization and stuff like that. Oh yeah, 3 types of casts. Okay, I can do that. Casts are actually a really interesting thing. Okay, so I will save it for ideas. Okay, I will write ideas, and so pointers with references with objects is good. Okay, typecasts. Any other ideas on what should I talk about? I will definitely include both things in my future sessions. So let me know if you have other ideas. Maybe people on Twitch also want to know something about certain C++ concepts. What's going on YouTube? Okay. How multiple entire inheritances works and where it is used. Oh, that's very advanced topic. Okay. Multiple, but since I promised that the course isn't, I didn't promise, but I suspected that the course is going to be non-linear. I can do that. So there is no particular order. Or it's better to say there is almost no particular order in which C++ concepts will be explained. So sometimes I will take people requests and explain things like multiple inheritance. Where it is used. Okay, other ideas. So I'll probably start with this topic, then I move to typecasts, and then probably multiple inheritance. Okay, maybe other people have ideas because let me write it down. I will actually reflect on them and think what else could I maybe there is. So I will reflect on these ideas and I will come up with some other stuff that I could talk about. What's going on IRC? There is just some fun stuff. So yeah, you can go to Watch People Code on Freenode to chat with us. Yeah. Okay. So, okay, if you have ideas about future live streams, send me an email or chat with me on Watch People Code at on irc.freenode.net, or just PM me on Reddit. So that's how it works. Okay, I guess there are no ideas, and I will end the stream. I really appreciate all your support, and thank you very much for watching. So this sort of course is just a huge experiment for me, and well, yeah. Thanks for watching. Thanks for all your amazing comments in the chat. Yeah. Thanks for watching.